We are now done designing our cam. We're going to move on to the assembly process. To do that, we're going to go to Canvas and we're going to download this file. This file is a compressed file. So when we open it up, we actually cannot use these files. So we need to uncompress them. To do that, we're going to go up here to the Extract tab. We're going to click on Extract, and then we're going to click on Extract All. Here we need to select our file path. So we're going to click on Browse. We're going to go down and find this PC. We're going to open that up. We're going to scroll down to P drive. We're going to open up our P drive and we're going to create a new folder. This folder you want to name 4.5. From here, you're going to notice, if you set it up right, that you will have your folder in the P drive. Mine was placed in the C drive, so I will end up deleting that folder. I will refine the P drive. I will select the P drive this time and then hit Make New Folder and then label 4.5. Now you'll notice our pathway is updated to P drive 4.5. From here we're going to hit Extract. Now we can use these files. So we're going to open up our folder and we're going to click on Automata Simulation. It says, would you like to update? Yes, we would. From here, this is our design automata box right now. We're going to be using this to test out our cam to figure out our displacement values for our follower. First thing, we're going to hide the box. To do that, we're going to right click and scroll down to Visibility. So now we need to place our cam. We're going to go to Assemble, the ribbon, and we're going to click on Place. If Place isn't here, click on the tab and you can find Place. Then you're going to find your cam file. Open it up, and now we're going to left click and place. We can keep clicking to place more parts, but we only need one. Now we can right click and hit OK. Now we're going to do some constraints, very similar to design and geometrical constraints, but these are assembly constraints. So we're going to click on Constrain. In this window we have different types of constraint. The one that we're going to mainly use is called the mate type constraint. For this mate type constraint we have two different solutions, mate and flush. Mate is how we take two surfaces and we glue them together, while flush is where we take two surfaces and we put them even to each other. So we need to place this cam onto our axle handle. So we're going to go and place our axle first. So we're going to find our work axis and we're going to click on that. We're going to do the same for this shaft. So our cam's moved. Yours might not have moved the same as mine, but that's fine. We still need to restrict some degrees of freedom. So we have a plane here for our axle handle and our plane right here for our cam. We want them to be glued together so the cam rotates with our shaft. So we're going to use a mate type constraint and we're going to use the mate solution. We're going to select these two planes. Now notice how they're not really selecting for me. You might need to rotate and find the orange side of a work plane. And I'm going to zoom in and select that. You'll notice that my handle flipped, and that's totally fine. Now both those planes are aligned. They're mated together. Now we need to position our cam. So we're going to use the flush constraint. We're going to take our plane that's intersecting the cam in the center, and we're going to line it up to the center of our follower. From here we're going to hit OK. And if we did everything right, you should be able to grab your handle and rotate like I am doing right now. Now if your cam is hitting your follower right here, just grab your follower and pull it up so it's up and out of the way. Next thing we're going to do, we're actually going to apply a constraint so that our follower will stick to our cam's profile, our edge. So we're going to click on Constraint again. This time, instead of an assembly constraint, we're going to do a transitional constraint. It's very important that you select the bottom of our cam follower first compared to our cam's edge. So select the follower's rounded edge and then select the side of your cam. After we hit OK and we rotate our system, you're going to notice that the follower sticks to the system. Now the next thing we need to do, we can't really measure accurately in a situation like this. We actually need to control the degrees that our cam is going to rotate. To do that, we need to do a little bit of a setup. First thing that I'm going to do though is go to our follower, and I'm going to expand our part so that we can find its origin folder. So I click on the little plus box, I find the origin folder, I open that up, and I'm now hovering my mouse on our origin planes to find an intersecting plane. So for mine it's XZ, so I'm going to click on that, I'm going to go up to work features, and I'm going to hit offset from plane. I'm going to hit OK. From here I'm going to start toggling some visibilities for planes. There's quite a bit of planes and it's getting really confusing on what's going on with our assembly. So we can go underneath our follower part and find mate with midplane, a cam. We can toggle the visibility to that. So right click and hit visibility. I'm also going to toggle the plane for our axle handle. So work plane 1, we're going to toggle that. I'm going to go to my cam and I'm going to toggle my plane that is splitting the cam right down the middle. So mine is work plane 1, yours might be as well. From here I'm going to go back to constraint, and this time instead of a mate type assembly constraint I'm going to do an angle type. I'm going to select my follower and then my work plane 2 for our cam here. Make sure that we're using the directed angle solution and then hit OK. If you try to move your system now, it won't let you. If we look in our browser underneath your cam, you're going to see an angle constraint. If we double click where it says 0 degree, we can actually enter in how many degrees we want this system to rotate, which we can see now it's updated. It says 60 degrees.